Electricity and plumbing students, Mr. Voigt here. I'm going to go over a combination circuit, a simple combination circuit. There's going to be two videos. This video is going to be a combination circuit where our main circuit is a series circuit. So if I come here and I were to go straight down in this way, that is a series circuit. Now obviously at this point it goes two directions, and then again at this point, at this point it goes two directions. What we're going to do in a combination circuit, the main idea is to collapse parts of it down. Anywhere where you have more than one resistor, if we can combine those together, so if I can combine R1 and R2 down into what we call RC1, resistance combined 1, if I can find values for those and combine them down into 1, there's only one resistor there. If I can combine these down into RC2, there's only going to be there's one resistor there. So we combine that parallel circuit down, combine that parallel circuit down into one, and then if I only have one resistor there and one resistor there, I have a series circuit. So my total over here, right? So to find my totals, I reduce my two circuits combinations over here down, if that makes sense. It should as we go through here. The second video is going to be just the opposite, where my main circuit is a parallel circuit and I have two series circuits inside of it, and so I simplify those series circuits down into one resistor per branch and so forth. So anyway, we'll deal with that later. Now what I've done here on the bottom of this page, there's a typewritten small thing on it, small chart. I wanted you to be able to see these numbers better as I do them, so I just went ahead and drew it out. I also have, this is on the spreadsheet, so I want you to take the numbers we do here and put them on the spreadsheet. Okay, so as you can see, what we know at our total, we have 24 volts. And we know at R1 we have 100 ohms, so R1 100 ohms, R2 250 ohms, R3 350 ohms, and R4 200 ohms. So our goal is to get at least two variables at every one of these resistance points, right? R1, R2, and R3, so RC1, I'm sorry, this isn't R3, this is RC1. So these are in parallel, and this would be like our total for this parallel circuit. These are in parallel, and this is like our total for this parallel circuit. So if we understand, and obviously RC1 and RC2 are going to be in series with our total. Okay, so how do we start? We start because really all we know is ohms down here. So if we can find ohms at our totals here and here, okay, then we can take those two answers because they're in series with everything here. And if you look at your rules, your resistance rules for a series circuit is the sum of the resistance points in a series circuit equal the total resistance. Well, in a parallel circuit, what it says is that total resistance is always less than any individual resistor or branch. So what we get here should be less than the lowest of our two numbers here. What we get here should be lower than the lowest of our two numbers here. So this should be less than 100, this should be less than 200. Now, in a parallel circuit, you haven't gone over this yet, you got to use the formula, the reciprocal of the reciprocals, for finding your resistance. So I'm doing this circuit right here. So 1 over 100 plus 1 over 250 is going to get us the resistance right here. The reciprocal of the reciprocals. That's how they say that. So on my calculator, I type that in this way. 1 divided by, then I got to use parentheses. So I'm going to go 1 divided by, in a parentheses, that's the big parentheses, then little parentheses, 1 divided by 100, close parentheses, plus 1 divided by 250, closed. So that's how I have to write it. So I'm going to go ahead and clear this. 1 divided by, open, 1 divided by 100, closed, plus, open, 1 divided by 250, closed, equals. So I get 71.429. So I get 71.429 ohms. Is 71.429 ohms less than 100? And the answer is yes. So I'm following my parallel rules here. So we're going to do the same thing here. 1 over 350 plus 1 over 2, or 1 divided by 1 over 350 plus 1 over 200. So to write that out, it would be 1 divided by, open, 1 divided by 350, closed, plus opened, 1 divided by 200, closed. That's how you write it. And I type it in exactly the same. 1 divided by, open, 1 divided by 350, closed, plus open, 1 divided by 200, closed, equals 127.273. 127.273 ohms. Okay. So now we used this formula, reciprocal of the reciprocals, to find our total resistance in a parallel circuit. We did it here too. Now because this one and this one are in series with our final one, we can just add these two together. So 127.273, oops, I better turn it on, 127.273 plus 71.429, 71.429. Then we get I didn't do that right. 71.429 plus 127.273 equals 198.702. 198.702 ohms of resistance total. So now, if you look, we have two variables here. So this is where we're going to work from. And if you look at you guys should have your rules out for your circuits. If we find amps in a series circuit, the rule is the amps are the same everywhere in a series circuit. So if we find this, we can put it here and we can put it here. And then we'll have two variables there. So let's do that real quick. To find amps, volts divided by resistance is what we're going to do. So clear 24 divided by 198.702, and we get 0.121. We're going 3 decimal places after. If you've looked, I've gone 3 places after the decimal. That's what we're rounding to. Don't round to 2, don't round to 4, round to 3. So 0.121. So I can put 0.121 here, and I can put 0.121 here. Right? So now at these two resistance points, I can find my volts. I'm leaving my watts till the end here. That's a good practice, typically. Not always, but typically. So if I want to find volts, and I know amps, and I know resistance, I multiply these together to get my volts. So 0.121, whoops, typed it wrong, 0.121 times 127.273, and I get 15.400. So this is 15.4 volts. And over here, 0.121 times 71.429, and we get equals 8.643. So 8.643 volts. So now if you look at the rules because remember, this is in parallel with those two, and this is in parallel with those two. If you look at your rules, and we're going to have to look up here, the applied voltage, so the applied voltage for this one, between here and here, our applied voltage is 8.643. It's going to equal the voltage through this branch, and it's going to equal the voltage through this branch. Since we only have one resistor in each one of those branches, that's going to be our voltage at that one resistor. So it's going to be 8.643, 8.643 And this is going to be the same way, right? Now, if we had two resistors in here, it changes things, but we don't. 15.4, 15.4. Okay. So now we have two variables at all the places. So I'm just going to go ahead and fill in my amps here. Amps is always volts divided by resistance. So 8.643 divided by 100. And I'm going to get 0.086. 0.086 amps. I'm going to go 8.643 divided by 250. And I get 0.035. 0.035 amps. Now, in a parallel circuit, your amperage the amperage of each branch, which is what these are, should add up to our total. So 0.068, 0.086 plus 0.035 equals 0.121. So that works out. I always go back and check it. So anyway, 15.4 divided by 350, and I get 0.044 amps. 15.4 divided by 200, and I get 0.077 plus 0.044, 0.121. So that all works out. So perfect. So now I'm done except for my wattage. The thing about wattage is, whether it's parallel or series, it's always volts times amps, always. And it's always the wattage of my total can always be derived from adding my resistors. Okay? So my total here should be able to be this plus this plus this plus this, or the same thing would be this plus this, because these are our totals of those, right? So we're going to go ahead and do our total here, volts times amps. So 24 times 0.121, and I get 2.904 watts. I'm going to go ahead and do this. 8.643 times 0.086, and I get 0.743. 0.743 watts. 8.643 times 8.643 times, I'm doing a bad job here. 8.643 times 0.035, 0.303. Okay, so if I add that and that, I should be able to get this. So that's going to 0.303 plus 0.743, and I get 1.046. Now, if I calculate this by going this times this, I should get something either identical to that or very, very close. 8.643 times 0.121, and I get 1.046 when I round, which is exactly the same thing. So I calculated it, or I add it, and I can get this. All right, so I'm going to go ahead and calculate my last two. 15.4 times 0.044, 0.678. 15.4 times 0.077, 1.186. If I add those together, plus 0.678, I get 1.864. Okay, so if I add these two together, I should get this number, If I add all four of these together,